Hello students, I am Surendra Jain, Master Teacher in Vedantu, and I have brought a series for KVPY SA stream preparation for mathematics. Today I will be talking about number system, in which I will tell you important thing about divisibility tests, some property of powers of natural numbers, and many more. So let us start with this. So if we want to know how a number is divisible by 2, 3, 4, 5, 6, 7, 8, 9 and 10 and 11, then these are few very important and very simple tests like for 2, 5, 10. You just have to check the unit place of that number. For example, if I talk about 524, if unit place is divisible by 2, then it will be divisible by, this complete number will be divisible by 2. Same goes for 5 and 10. So this will be divisible by 2 but not by 5 and 10. Similarly, if you are looking for divisibility by 4, then you have to check the last two digits. So 48 is divisible by 4, hence this number will be divisible by 4. For 8, we have to check the last three places. So in this number 1278, we will be checking only 278. If it is divisible by 8, then this number will be divisible by 8. But I think it is not 8 3s are 24, so it is not divisible by, yeah. So this number is not divisible by 8. Now coming to divisibility test of 3 and 9. One very interesting thing about number system, about this divisibility test here, that any number will be divisible only if sum of its digits are divisible by these numbers 3 and 9. For example, 4, 3, 2, 9, if you take their sum, it is 4 plus 3, 7 plus 2, 9 plus 9, 18. So this number is 4329 and sum of digits is 18. So because sum is divisible by 9, as 9 divides sum, hence 9 will divide that number also. And same goes for 3. That is because 3 divides this sum of digits, hence 3 will divide this number also. In fact, one very important thing to know about these sum and number is that this number is always congruent to the sum of digits mod 9 or 3. You can take with 9 also, you can take with 3 also. Listen carefully, if a number is not divisible by 9, let us say this is the number, then sum of digits is 7 plus 3, 10, 10 plus 9, 19. So you can see if you divide this sum by 9, then your remainder comes out to be 1. Then you can check that remainder here will also be 1 only. So same will be the remainder if you divide the number or the sum of its digits. That is why I am saying that this number n is congruent to the sum mod 9 or 3. Same goes for 3 also. Okay, now coming to divisibility test of 11. Very simple. If the difference between sum of odd numbered digits and sum of even numbered digits counted from right to left is divisible by 11, then sum is divisible by 11. For example, for this number, if you count the sum, so 7 plus 2 plus 5, I have taken from right to left, and then you can take the sum, it is 7 plus 2 plus 5, it will be 14. The other numbers are 3 plus 0, their sum is 3, and you can see the difference is 11, hence this number will be divisible by 11. I think these tests are very popular, many students may be knowing, but there is one test of divisibility by 7 which many of you may not be knowing. Please see what it is. Suppose you have a number n which is AB. AB means B is the unit place. So in this example, B is 3 and rest all the things like 3842 is A. So B is the unit digit and A represents the remaining digits. Then n will be divisible by 7 if and only if A minus 2B is divisible by 7. Please see what I am trying to tell you. In this case, A is 3842 and B is 3. So minus 2B will be 6. So we get here 3836. Okay. So this number 38423 will be divisible by 7 if this is divisible by 7. It again seems to be big number. So we will be again making new A and B's. So this will be A and 6 will be B here. So 383 minus 2 times B, that is 12. We get 300 and 71. Okay, you can divide 371 by 7 and you can check it is divisible by 7, or if you want to do this thing once again, you can do it. 371, I will call 37 as A and 1 as B. So 37 minus 2 is 35, and you can check 35 is divisible by 7, and hence 371 is divisible by 7, and hence this 3836 is divisible by 7, and hence this number is also divisible by 7. Okay, so this is how we check for a bigger number if it is divisible by 7 or not. But why it is happening so? Please see. Suppose your number n is subtracted by 10 times a minus 2b. Okay, and this n here is, let me write it here, this n here is actually 10a plus b. If n is 10a plus b, and if you subtract 10 times a minus 2b, you get 21b. Which means this difference of n with 10 times a minus 2b will always be multiple of 7. Isn't it? It is multiple of 7. So if this n is divisible by 7, this 10 times a minus 2b has to be divisible by 7. But because 10 is not divisible by 7, so if 7 divides n, then 7 divides 10 times a minus 2b, and you can remove this 10 because 7 doesn't divide 10, so this 7 will divide 10 minus 2b also, and it is actually both ways. It is both ways. So this is the test of 7. One interesting thing I would like to ask you, as I told you in the case of divisibility test of 9, where sum and number, they were congruent mod 9. So my question here is whether this number n will be congruent to a minus 2b mod 7 or not. Please think about it and let me know. It is a question. I am not saying it will happen. You just have to check. Is it true or not? Okay. Now some important facts about square, cube and 6 power of integer. Any integer, if you do the squaring, let me write some squares like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121 and so on and so on. You can check square of any integer will be either multiple of 4 if it's an even number, but if it is not even number, then it will be of the form 8k plus 1, which means if you divide perfect square by 8, it will give you remainder as 1. You can check 1, 9, 25, all squares of odd numbers are example of this. Similarly, if you look at these numbers from the point of dividing by 3, then you will find all these squares will be of the form either 9k if number is multiple of 3, or it will be 3k plus 1 form if it is not multiple of 3. It cannot be 3k minus 1 or 3k plus 2 for any number. You can check all these numbers. Similarly, if you divide these perfect squares by 7, you will find either these squares are multiple of 49 or they all are of the form 7k plus 1, 7k plus 2 or 7k plus 4. That means if you divide them by 7, their remainder will be either 1 or 2 or 4. Nothing else can happen. Similarly, if you look for the cube of any integer, it will be 27k if it is the multiple of 7, or it will be 9k plus minus 1. Similarly, if you look from the point of 7, then it will be either 7k, rather it will be 7 cube into k if number is multiple of 7, otherwise it will be 7k plus 1 or 7k minus 1. 6 power of any natural number or integer, it will be 7k or 7k plus 1. See, such things will help you to eliminate some of the possibilities, and that will lead you to a good solution of a given question. Okay, now let us do one question based on what we have done so far. Question says find the least natural number divisible by 36 which has all 10 digits in its decimal representation. Okay, so first of all, if I write all the 10 digits in decimal representation from 0 till 9, their sum comes out to be 45. You can check. which means because sum is 45 which is divisible by 45, so whatever number you create by using all these digits has to be divisible by 9, isn't it? Okay, so call this as sum, and then whatever number you create using 0 to 9 all distinct digits, then it has to be divisible by 9. But we want this to be divisible by 36. So 4 should also divide this number. Okay, and as you know, the divisibility test of 4 is that last two digits should be divisible by 4. Let me write all 10 digits here: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now because we are looking for least possible natural number, okay, then definitely I will like to have least possible number here, maybe 1, and largest numbers at the last two places. But at last two places we have to have numbers such that they are divisible by 4. Then I think these numbers can be 96. You can check. 96 is the highest two digit number which is divisible by 4. Then it becomes 100, which is 3-digit number. And having 96 at the last two places will give you least numerical values of 9 and 6. And then to get least possible number, I think I should put 0 here, then 2 here, 3 here, 4 here, 5 here, then 7 here because 6 is already used, and 8 here. I have already told you whatever rearrangement, whatever arrangement of these numbers can be, it will be divisible by 9. And by taking 96 at this place, we have made sure that it will be divisible by 4, and hence it will be divisible by 36. Just one thing I would like to add here, that suppose instead of 96 you would have taken 92 here. Then you will be writing some bigger number at this place than 2. And then this number will be bigger than what we have obtained here. Though this number will also be divisible by 4, and hence complete number will be divisible by 36, but it will not be least natural number. So to get this least natural number, I think that is the answer. Okay, so this completes the solution of this question. Now coming to question number 2, very interesting question. It says 2 raised to the power 29 is a 9-digit number with distinct digits. Which digit is missing? We are not supposed to find the value of 2 power 29. Rather, they have given that it's a 9-digit number with all distinct digits out of 0, 1, 2, 3 up to 9. We have to just find which digit is not there. And how can we do this? Let me tell you, this can be done with the help of divisibility test of 9. Please see how. This 2 power 29 I will write as 4 into 8 raised to the power 9. 9 into 3, 27, plus 2, 29. Yeah. Now there are two ways. One, if you know Converse Modulo, then you can do it even faster. But if you do not know, then also it can be done. Please see how. I will write 4 into 8 power 9 as 4 into, I can write this as 512 raised to the power 3. And this will be 4 into 513 minus 1 raised to the power 3, because 513 is divisible by 9. Please check. 5 plus 1 plus 3 is 9. So it is divisible by 9. So if we open this cube, we will be getting 513 cube minus 3 into 513 square plus 3 into 513, and in the end minus 1. Okay. All these terms are divisible by 9. Hence the remainder here would be minus 4, which we can also write as 5. Now same thing can be done by Converse Modulo also. Please see how, because 8 is congruent to minus 1 mod 9. So using the property of Converse Modulo, if I raise both sides by 9, it will become like this. And if I multiply by 4 here, both sides, it will be 4 into 8 raised to the power 9 is congruent to minus 4 mod 9. So this way also you can check that remainder will be equal to minus 4 or 5. It's the same thing. When we study in 9th, 10th class, I think we always take remainder as positive number, but it can be negative also. You just have to add that number by which you are dividing to get the actual remainder. Whatever you are comfortable with, it is fine. Now please see, if I take the sum of all digits, Sum of all digits means 0, 1, 2 and so on up to 9. It is actually 45. Please remember it. It is useful at many places. Now, because this number is such that when divided by 9, it gives you remainder 4. Okay, when divided by. Now the property of divisibility of 9 is that you should get same remainder whether you divide that number or the sum of the digits. So because sum of all 10 digits is 45 and it is having 9 digits, so one digit is missing. So this digit that is missing should be such that that remaining sum should also give you remainder as 5. Okay, so what number should it be? Can it be 9? I don't think so, because then sum will be 36, which is divisible by 9. Can it be 8? Then it will be 37. Once again, then remainder will be 1, so it is not possible. So if you check, I think this missing number has to be 4, because then sum will be equal to 41, and you can check 41 when divided by 9 gives you remainder as 5, which we were getting for 2 raised to the power 29 also. So here answer will be 4, C option. Okay, chaliye, next question. Coming to question number 3, it says state true or false, and you are given that natural number m and n are such that 21 divides m square plus n square, then 441 also divides m square plus n square. We have to find whether it is true or not. Please see. As we know, 21 is 3 into 7, which means 3 will be dividing this m square plus n square, and also 7 will be dividing m square plus n square. Now, please remember, I just discussed that what are the properties of square of a number. You know that square of a number is of the form either 9k or it is 3k plus 1 if we look from the point of view of dividing by 3. Okay, now suppose your m square is 3k plus 1, because square of any number is either 9k or 3k plus 1, then you cannot choose n square such that, because n square will be either 9k or it will be 3k plus 1. In both cases, your sum cannot be multiple of 3. Cannot be multiple of 3, isn't it? 3k plus 1 and 3k plus 1 if you add, you will get 2 remainder if you divide by 3. But we are given that 3 divides m square plus n square. So only possibility is that m square should be equal to 9k and also n square should be equal to 9k. That means not only 3 will divide, 9 will also divide m square plus n square, because both m and n will be multiple of 3. So their square will be multiple of 9 and hence 9 will divide this. Now similar to this, if we look the square of a number from the point of view of division by 7, then it is either 49k or it is 7k plus 1 or it is 7k plus 2 or it is 7k plus 4. These are the only 4 possible scenarios. If you can see 49k, 7k plus 1, 7k plus 2, 7k plus 4. This we have discussed already. Okay, so here if you take m square to be any these 3 of 7k plus 1, 7k plus 2 or 7k plus 4, let me write 7k plus 1 or 7k plus 2 or 7k plus 4. Then in order m square plus n square to be divisible by 7, I will require 7k plus 6 here, or 7k minus 1 also you can say. But as we know, there can be no square which can be of the form 7k plus 6, so it is not possible. Similarly, if m square is 7k plus 2, then this sum to be divisible by 7, I will need 7k plus 5, but that is also not possible for any square of an integer. Similarly, for third case, we will require a number of form 7k plus 3, but that is also not possible for square of any integer. So this is also not possible. So what is the remaining possibility then? The remaining possibility is that m square has to be 49k, and then n square will also be 49k. That means this 49 will divide m square plus n square. Actually, in this case also, this m and n both will be multiple of 7 each. So their square will be multiple of 49 each, and hence their square will be divisible by 49. So because 9 and 49 are co-primes, and 9 divides and 49 also divides this m square plus n square. So combining them, their product, I think, which is 441 only, should divide m square plus n square. So this is how this question is done, and hence this question will be true. I think very recently there was a question similar to this only, where they gave 3 numbers, I think A, B, C, and some of their squares were asked if it is divisible by 9 or not, something of that sort. So you can check that out. So this question is very much similar to that only. So coming to the next question, question number 4, one very interesting question. Please see what this is. It is saying that find sum of all 3-digit numbers, any power of which ends with 3 digits forming the original number. What does that mean? Please read this question once again. We want 3-digit numbers so that if you raise it by any power, let us say n, you should get the last 3 digits, these digits only. So suppose you have A, B, C and you want to raise it by n, then it will be having A, B, C in the end. Maybe X, Y, Z can be here, but last 3 digits should be A, B, C. Now my one of the observation or my one claim here is that if I do it for square only, and let us say this number has property that it is having X, Y, Z at first 3 places, and then A, B, C in the last 3 places. Then if you take cube, then also this will hold, because XYZ into ABC, XYZ then ABC multiplied with ABC, the last 3 digits will be decided only by product of this ABC with this ABC, because XYZ has a numerical value equal to XYZ into 1000. So here you will be having ABC in the last 3 places. Maybe your first places can be U, V, W, T, R, something like that. But last 3 places will be ABC. And similarly, if you raise it by 4 or 5 or 6 or higher power, your last 3 digit will remain ABC if this is a property for square. So I think we just have to check for square, then I think we are done. Now please see, if ABC square is equal to XYZ and then ABC, that means unit place here is C and here also unit place is C. So we have to look for such numbers whose squares gives you the same number at their unit place. So here the possibility of C can be 0, because C square, 0 square is 0. Or it can be 1, because 1 square is 1, but it cannot be 2, it cannot be 3, it cannot be 4, it can be 5, because 5 square is 25, it can be 6 also, but it cannot be 7, 8 or 9. You can check. 7 square is 49, 8 square is 64, 9 square is 81. So these are 4 possibilities for C. Now let us solve them one by one. If I take C to be equal to 0, then my number will be A, B, 0. And if I take square of this, it will become, it will be taking actually 2 zeros in the end and maybe some X, Y, Z here. Okay, but, and also I think the third last digit should be A here. Third last digit should be A here, because we want this property that A should be the number at the hundreds place. So if I compare these 3 digits with A, B, 0, so we get B to be 0. So actually, if C becomes 0, my tens place should also be 0. So that means my number will be actually A, 0, 0. And if I take square of this, I think it will have 4 zeros in the last 4 places and maybe some UV here. So again, if you compare last 3 places with A, 0, 0, you can check your A should be 0. So actually we are getting number to be 0, 0, 0, whose whole square can be written as 000, no doubt, but this is not a valid form of writing a 3-digit number. So no possibility here, no possibility here. If your unit place is 0. Now coming to the second case. Now coming for the second case when C is equal to 1. If C is equal to 1, then my number will be AB1 and its square I can write as AB into 10 plus 1 whole square. Okay, then we can write this as AB whole square into 100 plus 1 plus AB into 20. You can check this term is having unit place and tens place both has 0, whereas this is having unit place as 0 and this is just 1. So unit place is sorted, 1 here, 1 here. But if we look at the tens place, okay, if you look at tens place on the right hand side, it will be determined only by unit digit of 2b. Yes or no? Because A has numerical value as A into 10. So multiplied with 20, it will give you last two places as 0, 0. So only B when multiplied with 2 will give you something meaningful at the tens place of your right hand side. And it will be decided by the unit digit of 2b. And we want this to be B. We want this to be equal to B. So either 2b itself will be equal to b, but I think this is giving you b is equal to 0, or maybe 2b becomes 2-digit number, then its unit digit will be 2b minus 10, because b, if it is 5, 6, 7, 8 and you multiply it by 2, then it will be number greater than 10 but less than 20. So 2b minus 10 will be equal to b, but then we are getting b to be equal to 10, which does not seem to be possible. So only possibility here is b is equal to 0. Now our digit, now my number has now become A01. If I do the square of this, we will get, I think, A into 100 plus 1 whole square. So if I expand it, we get A square into 10,000 plus 1 plus A into 200. Okay, so here you can check on the right hand side, last two places in this term are 0. In fact, last three digits of this term are 0, 0, 0 only. In this case, A into 200, last two digits will be guaranteed 0. But for hundreds place, if we look on the right hand side, it will be decided by unit digit of 2A. Unit digit of 2A. Okay, and this will be equal to either A, or if 2A is greater than 10, 2A minus 10 will be equal to A. So once again we are getting A to be 0 or A equal to 10. I think A equal to 10 is not possible. A is equal to 10 is not possible, but A equal to 0, if we take, then my number, because I got C as 1, I got B as 0, and then A is also 0, then I got this number to be, please see, 0, 0, 1, which is once again, if you do the squaring, you get 0, 0, 1 you can write, but it is again not a valid form of such number, so not possible, not acceptable you can say, or no such possibility. Okay, now coming to next case when C will be equal to 5. Please see, if I take C is equal to 5, my third case, my number will be AB5. And if I do the squaring of this, we will get AB into 10 plus 5 whole square. Okay, and if we open it, we will get AB whole square into 100 plus 25 plus 2AB term will be, I think, AB into 100. So you can check these two, both of them are having last two digits as 0, 0. Okay, so last two digits will be decided by only this 25. So if we want AB5 to be in the end on the right hand side also. So we get here, I think b to be equal to 2. So b will be equal to 2. You can check. Unit place is 5 here. We want tens place also same as on the right hand side. So b is equal to 2. So my number now would be, let me write this as a25 whole square. And I will write this as a into 100 plus 25 whole square. So we will get this as a square into 10,000 plus 625 and plus it will be a into 5,000. Yeah, 5,000. So at hundreds place, if you check, you cannot get any value other than 0 from here or from here. So at hundreds place, I think we are getting 6 here. So my a should be equal to 6. So in this case, I think we have got a solution, and this is ABC is equal to 625 because A is 6, B is 2 and C is 5. So one possibility is there, and I think only one possibility when C is 5. Now there was one more case when C is 6. Okay, let us see if we get one more or few more solutions here or not. So if C is equal to 6, okay, then my number will be A, B, 6. And I do the squaring of this, we can write this as AB into 10, AB into 10 plus 6 whole square. So this will become equal to AB square into 100 plus 36 plus AB into 120. So unit place is sorted. If we look at the tens place of the right hand side, it will not be decided by this. It will be decided by this and this. Okay, so it will be sum of 3 plus, please listen carefully, because 120 has 0 at the unit place. So it will be decided by unit place of 2 into b. Actually unit place of 3 plus 2b, and it should be equal to b. So either 3 plus 2b will become equal to b, but I think this is giving us negative value, which is not possible. But if 3 plus 2b becomes greater than 10, its unit place will be 3 plus 2b minus 10 is equal to b. In that scenario, b will become equal to 7. So we are getting one acceptable solution here. Also, if 3 plus 2b can become greater than maybe 20, then also you can check. I think we are getting b to be equal to 17, which is also not possible. So here we are getting only one possibility, that is b is equal to 7. Now let us write this once again. So my number will be a, at b I will write 7, at c I will write 6. So a 76 square, and it will be a into 100 plus 76 whole square. Okay, if we expand it, we will be getting a square into 10,000 plus 76 square plus 152,000 into a. Now we are looking for hundreds place. Okay, and at hundreds place it will be decided by, on the right hand side it will not be decided by this, because hundreds place is 0 here. It will be decided by hundreds place of 76 square, and I think 2 multiplied with a, because last two places are 0 0. So it will be decided by unit place of 2a plus the hundreds place of square of 76. Let me do the 76 square here. How much is the 76 square? Let me check. 76 into 76. So it will be 3645. Yeah, and then it will be 2, and it will be 53. Yeah, so it will be 6 here, it will be 7 here, it will be 7 here, it will be 5 here. So I think I will need this number here, because hundreds place we are looking for. In the square of 76, hundreds place is 7. So unit place of 2a plus 7 will decide the hundreds place of the right hand side, and we want this to be equal to a. So 2a plus 7 will be equal to a, but I think this gives a negative value. Okay, so if 2a plus 7 becomes greater than 10, we will write its unit place like this: equal to a, gives you a is equal to I think 3, which is acceptable value. It can be checked whether it can become greater than 20 also, but then I think a becomes 13. So that is also not acceptable. So in this case, when C is 6, we got B as 7 and A as 3. So in this case also we have got a solution: A, B, C as 376. Okay, so the sum of all three such digits we are looking for. So one such number was 625 and one such number was 376. If you add them, I think the answer here would be, where is the place? Let me write it here. Just 1 minute, yeah. So sum, that required sum which we are looking for is 625 plus 376. So it will be 1001. That is the answer. So one very interesting question, and I hope you like this solution. Now coming to question number 5, this is a question from previous year KVPY. It says a 5-digit number A, B, C, D, E when multiplied by 9 gives 5-digit number E, D, C, B, A. Just reverse the digits. Then you have to find the sum of digits in the number. If this EDCBA is multiple of 9, then its sum of digits has to be multiple of 9, isn't it? And if we look at the options, I think they have given all such options only which are multiple of 9. So we cannot eliminate any option because of this thing. But yes, we have some other option. We have some other method. Let us see. So if you are multiplying A, B, C, D, E with 9 and you get this to be ED, CBA, and both are 5-digit numbers. Okay, then this A has to be 1, because if A is 2 or bigger number, then product with 9 will give you 6-digit number. It cannot be 5-digit number. And also if A is 1 and you multiply this A with 9, your last digit here will be 9 only. E will become 9. So we have found first digit as 1, then B, C, D we are not sure, then 9 here into 9 is equal to 9 D, C, B and A. Now let us talk about B. Please listen that 1, 1, 1, 1, 1, 5 times 1 actually multiplied with 9 gives you the largest possible 5-digit number, that is 9 5 times. Okay, so here B cannot be, this B cannot be greater than or equal to 2. It has to be either 1 or 0. Okay, so if B is 1, which is also possible from this calculation it looks like, but then if B is also 1 and you multiply this 9 with B here, then I think product at D will also become 9 only. Okay, if B is 1, then this D will also become equal to 9, because if this B is 1, then multiplying 9 with 1 will give you 9, and then multiplying 9 with this one will also give you 9. So taking B as 1 will make D also 9. So our number will become 1 1 C 9 9 into 9, and it should give you 9 9 C 1 1. Now because of this product here, you can see this C can be 0 only. C can be 0 only. Then only it is possible to have product that will be of 5-digit. Okay, but if C is 0, then you can check sum of digits. Sum of digits. If you check both sides, it will be 1 plus 1 plus 9 plus 9, that is 20. So this cannot be multiple of 9. So C is equal to 0 is not possible. In fact, this B is equal to 1 is also not possible, because C is equal to 0 was the conclusion when we took B as 1, we got D also 9, then C 0. So that means so B is equal to 1, not possible. So what is the possibility remains? I think B is equal to 0. And if B is equal to 0, our number will be 1, 0, C, and then I think D I can write here, and then 9 into 9 will be equal to, on the right hand side, 9 D C 0 1. Okay, let me check if we can conclude it directly. Yeah, please see, if you multiply 9 with this thing, so my 9 into 9 is 81, my carry will be 8, and I want D such that multiplication of D with 9 plus 8 gives you 0 here. So that means D has to be 8 only. Please check, because D is 8, then 9 into 8 is 72, plus 8, which was carry when 9 was multiplied with 9, will give you 80. So I think D has to be 8. So my number here will be 10C 89, okay, into 9 will give you 9. In place of D I will write 8, then C, then 0 and 1. Okay, now please see, because this number has to be multiple of 9 and sum of digits, let me write it here, sum of digits, if you check, is 9 plus 8 17 plus 1 18 plus C. So C can be 0 or C can be 9. Then only sum of digits will be multiple of 9. So if I put C is equal to 0 here, if I put C is equal to 0, you can check this product will not match. Because if C is 0, it will be 100 at this place. Let me write it here. For C is equal to 0, it will be 10089, and if you multiply by 9, we cannot obtain 98001. You can check, because it will be 900 here. This is not matching. So I think C has to be 9. So answer for this sum will be equal to 18 plus 9, that is 27. So answer for this is B. And you can also check that the digits we have obtained, what, 1 0, C was 9, 8 9. If you multiply it with 9, you indeed get 98901. It can be checked. 9 9s are 81, 9 8 is 72, 80, 8 9 9s are 81, so 89 here, and 89 and then 9. Yeah, that is correct. So this is the answer for this question. Okay, now coming to the next question, it is again from previous year KVPY. It says A, B, C, D, E be natural numbers in an AP such that A plus B plus C plus D is the cube of an integer and B plus C plus D is square of an integer, then least possible value of number of digits of C is. Okay, so please understand that there is a property in AP that if BCD are in AP, then B plus D is equal to 2C. And same is true for A plus E also, because A plus E will be equal to B plus D and this will be equal to 2C. Okay, so if I talk about A plus B plus C plus D plus E, it will be actually equal to A plus B plus C plus D plus E will be equal to 5 times C. And we want this to be cube of an integer, let us say n cube. Similarly, B plus C plus D if I take, then it will be equal to 3C, because B plus D is 2C, and it should be equal to m square, square of some integer. Now please see, if 5C is a perfect cube, then your C must have at least 5 square in it. Otherwise, it cannot become perfect cube. It may have higher power of 5 also, but at least 5 square should be there in the C. Then only it will become a cube. Similarly, if you say that 3C is perfect square, then C should also have 3 in it, so that it has 3 square in it, which is a perfect square. But if you take C as only 3, then 5C cannot become whole cube, which means I have to have at least 3 cube in in the prime factorization of C. And now you can check. If I take 5 square and 3 cube, I think both relations are satisfied, because 5 into C will give you perfect cube and 3 into C also gives you perfect cube. In fact, you may have perfect cube of some other perfect sixth power of other number also in the prime factorization of C. Why I am saying perfect sixth power? Because this C, 5C is a perfect cube also, 3C is a perfect square also. So if you want that this k power 6, that other factor than 5 and 3 can be written as perfect cube as well as perfect square, it has to have power 6 of some integer k. Okay, so this this C has to be 25 into 27 into some k power 6. But we are looking for least possible value of number of digits of C. That means I will take this k as 1, so that C minimum value or C least will be 25 into 27, which is 675. So least possible value of number of digits, they are asking number of digits. So answer will be 3 for this question. So this is the solution of this question. Okay, coming to now, I'll be telling you a teaser question which we will be waiting for your solution, and we will revert you when we get a good solution from you. But before that, this is KVPY schedule, which started on 29th of May, and every week on Sunday you can get videos at these times for SA and SX both. Dear students, if you are going to appear in JEE Advanced this year or next year or next to next year, then Vedantu Eklavya is one very important thing you should know. It's a one big thing in online domain. If you know about it already, then it is fine. Else, just Google it, you will come to know. I'm sharing with you a useful link, some useful links. This is actually a notice board where you will come to know important information regarding new batches coming up or new things going on in these batches. This link can be accessed in your description box also. If you are going to appear in JEE Advanced this year, then this is a link to Telegram channel where you will find important informations regarding when new batches are coming up. Similarly, for 2023 aspirants and for 2024 aspirants, we have created one YouTube channel with the name V Impact, where you will find solutions of JEE Advanced, KVPY of these years 18, 19, 20, 21 for JEE Advanced and 18, 19, 20 for KVPY. These solutions are given question wise, and you will find alternate solutions also for these questions if there exist. Okay, now coming to teaser question, it says prove that for every positive integer n, there exists an n-digit number divisible by 5 raised to the power n, all of whose digits are odd. So read this question carefully and send your solution to us on this email ID eklavyasupport@vedantu.com with the subject name of email as teaser solution maths. Okay, we will go through your solution and we will revert with you. We will revert you on the same email ID from which you are sending the solution. We will interact with you if we find your solution to be good. Okay, so that is all from my side today. Thank you so much. Bye everyone.